All right, if you're building anything with AI, I'm sure you've run into this. Your agent is working perfectly, and then it just forgets what it's doing. Well, today we are diving deep into the solution, a really crucial new field called context engineering. It is all about mastering an AI's memory so we can build smarter, more reliable agents. So, let me ask you this. Have you ever had an AI agent that just loses the plot? Right? It gets confused, it gets distracted, or it completely forgets its main goal halfway through a task? It is an incredibly common and super frustrating problem for developers. The solution, it turns out, lies in this idea of context engineering. And I absolutely love this definition from Andrej Karpathy. He calls it the delicate art and science of filling the context window with just the right information for the next step. It's less about programming and more about being a curator for the AI's attention. Now, to really wrap our heads around this, let's use a simple analogy that's going to guide us through this whole explainer. I want you to think of the large language model itself as a computer's CPU. It's the core processor, right? It's doing all the heavy lifting. The context window, then, is its RAM. It's the AI's short-term working memory. It is unbelievably fast and powerful, but, and this is the key, it's also very limited. And that limitation, that finite amount of RAM, is the real source of what we're going to call the agent's memory problem. So let's break down exactly why this happens. So why are autonomous agents so susceptible to this? Well, it's because as an agent is working on a long, complicated task, its RAM just gets totally cluttered. Every single tool it uses, every piece of feedback it gets back, all of that stuff gets added to the context. And the more you try to cram in there, the higher the chance it's just going to get confused or distracted. When that context window, that RAM starts to overflow, things break badly. In fact, researchers have identified a few specific ways this goes wrong. You get context poisoning, where bad information corrupts the entire output. You get distraction, where it just loses focus on the main goal. And you get the AI tangled up in conflicting information. Okay, so if that's the problem, what's the fix? How do we actually manage this limited memory? Well, it turns out there are 4 key strategies engineers are using, and we're going to start with the 2 most fundamental ones: writing and selecting context. Let's go right back to our computer analogy. Writing is basically like saving information to a long-term hard drive. You're taking it out of that active RAM to store it safely for later. Selecting is the exact opposite. It's like loading a specific file from that hard drive back into RAM, but only at the precise moment the agent actually needs it. Let's break down that writing strategy a bit more. First, you've got Scratchpads. Think of this like an agent taking temporary notes on the side. For instance, researchers at Anthropic built an agent that writes out its entire plan to a file before it even starts, just so it can always refer back to it. Then you have long-term memory, which is for saving key information across multiple different sessions, which you've probably seen with ChatGPT's memory feature. Now, what about selecting? Pulling all that info back in? Well, an agent might retrieve specific facts from a knowledge base when needed, or maybe it pulls in a set of rules, like a style guide for writing code. But a really clever use of this is for tool selection. Imagine an agent has hundreds of different tools it can use. Instead of loading all them into context, it can use a retrieval technique. You might know it as RAG, to find and select only the single most relevant tool for the job at hand. Pretty smart. Okay, that makes sense. But what if all the information is essential? What if you actually can't just write it away to a hard drive for later? That's where some of the more advanced strategies come into play. So let's look at 2 more: compressing and isolating context. You know, modern models like Claude have these enormous context windows. We're talking over 200,000 tokens. To put that in perspective, that's like having a whole novel's worth of working memory. You'd think that would be plenty, right? But the crazy thing is, for truly complex, long-running agentic tasks, it is still never enough. And that's when you really need to get clever with your techniques. And that brings us to our 3rd strategy: compressing. This is all about keeping the important stuff and just getting rid of the fluff. A really common approach here is summarization. For instance, Claude can automatically summarize a super long conversation just to save space. The agents from Cognition AI do something similar. They'll summarize the results of one subtask before handing it off to the next. Our final strategy, isolating, is where things get really creative. The core idea is to just stop trying to cram everything into one giant context window and instead you split the problem up into containers. You could use a multi-agent system where each agent gets its own dedicated, clean context to work on its little piece of the puzzle. Or you could use sandboxing, which is like creating a separate, safe environment to hold heavy data, like images or files, so it never floods the main memory. And finally, you can use what are called state objects to organize all your context into different buckets, and then you only show the AI the one relevant bucket for whatever step it's on. This all sounds great in theory, but how do you actually go and build these systems? Well, let's take a look at the engineer's toolkit. Specifically, we can see how these 4 strategies are implemented in a super popular framework for building agents called LangGraph. And what's so powerful here is seeing how a modern framework like LangGraph gives you tools for each of these strategies right out of the box. For writing, its state objects basically act as a built-in Scratchpad. For selecting, it has native memory and RAG retrieval built in. For compressing, it's got utilities to automatically trim down your message history. And for isolating, it even has pre-built setups for multi-agent systems. The toolkit is literally being built around these core ideas.
And make no mistake, this isn't some niche optional skill. The team at Cognition AI, the people building some of the most advanced agents out there today, they put it very plainly. Context engineering is effectively the #1 job of engineers building AI agents. It is the core challenge.
At the end of the day, as these AI agents evolve from just being simple tools into truly complex collaborators, mastering their memory is everything. The 4 strategies we've talked about today are the foundation, but they also leave us with a really big question for the future. How are we going to continue to engineer these agent minds to think, remember, and reason even more effectively?